Hello, and thank you for joining this ETSI webinar. I am Emmanuel Bospordik from the ETSI events team, and I'm very pleased to welcome you all today for a webinar focused on the brand new OSM Release 17, extending its capabilities for cloud-native orchestration. The webinar will be presented by Francisco Javier Ramon, Chair of ETSI Open Source MANO from Telefónica. Hi, Francisco.
Hello.
Gerardo Garcia, TSC Chair from Telefónica.
Hello.
And Pedro Pereira from OSM, contributor of IT Avero. The webinar will last up to 75 minutes with a Q&A after the presentation. So if you have any questions to our presenter, please submit them in the Q&A questions box on your BrackTalk channel. And the questions will be addressed after the presentation, as said, if time allows. As usual, the webinar will be recorded and available on demand shortly after the end. But I think it's time to hear more about OSM Release 17, so I'm pleased to hand over to Francisco. Thank you, Francisco.
Thank you, Emmanuel. Thank you. So it's a pleasure to present a new OSM release. And we are quite excited with the evolution of OSM in the last releases and how the scope has evolved significantly. So we will do a quick recap at the beginning of the webinar, and then we'll have a deep dive on the features, and particularly on some of the key features we will be demonstrating then, so you can see them in practice. So as said, I will give an introduction on OSM and what is new in OSM that is worth your attention, and then Gerardo Garcia, TSE Chair, will be explaining how cluster management in public cloud works. And after that, with some demonstration, and after that, Pedro Pereira will be telling us about the new feature that of OSM Release 17 on relocation of CNFs in different cluster nodes. So the goal of OSM, for those who are not totally aware, has been extended since the last release. We have extended the scope that was mostly related to management of network functions in telco clouds to managing also related platforms and infrastructure. So the way of managing them together or per segments is as easy as possible. And that has led to a lot of innovation in OSM in many aspects, also benefiting the own network function and application management that is now more convenient, as we will see. And the thing is that the overall goal of OSM remains pretty much the same, but now extending it to that cloud infrastructure and the platforms that are related. So that gives us a better approach for the most complex scenarios, right? And we wanted to see that evolution, and we believe that was the way to go. So that led to a significant change also in the architecture, because we couldn't face that challenge without doing things a bit differently. So we could be better positioned for achieving those goals. So the things that in release 15 we were following an approach for imperative operations that were NFV-like operations in our origin, and we are quite proud of that origin. We wanted to provide a practical implementation of ETSI NFV with our own innovations. For instance, the day 1 and day 2 actions that were something that was unique in ETSI OSM, and that is what we call the gene for imperative operations. However, in the next releases, we have added a second engine. The other does not disappear, and there are no plans for discontinuing or anything, because we believe that is also quite useful. But now we are adding a second engine that is for declarative operations. So we can go in the path of configuration as data, Kubernetes-like operations, and more important, and we'll see the relevance in a minute, because that will provide us also a sound foundation for continuous synchronization and reconciliation of the resources. So we can guarantee that the state is the desired one during all the lifetime of the application. And that was introduced in release 16, but now in release 17, we are giving even more steps in that direction and consolidating what we have in release 16. And what are the declarative operations are about synchronizing the actual state in the clouds with some sources of truth that describe what is the state that we want to achieve there. And there is a mechanism in place that observes the potential differences in case there are any, and adjusts the state in the clouds automatically. And the point is that the sources of truth is where we store those intents, what we want to achieve, and we store them safely, so we can version them, we can use them as a time machine, we can have authoring, we have many pieces of control for data actually. So we can exploit all those techniques in our favor to make our life much easier. And this mechanism leverages on the Kubernetes ecosystem, puts in place a continuous reconciliation of intents as well, and all the tooling that is useful for Kubernetes and in general and GitOps practices can be naturally applied there. That is the advantage. So in this framework, as you are seeing, is that we can achieve any final state without acting directly with the clouds. Our relation with the clouds is indirect via the sources of truth. They will be quite important because they changes the way of work for the better. Okay. So this is quite good. However, this is GitOps. In the end, is what we are describing, some of the benefits of GitOps. And the point is, why do I need anything else? This is a consolidated concept that we can understand it, we can follow Kubernetes resource modeling to some extent. Perfect. The point is that it is not enough, because in a complex scenario, you need to maintain a lot of things manually, right? For instance, just to grant the synchronization order, you need to take it into account. I mean, a cluster needs to be ready before the workloads. Or you would like to minimize the duplication of the intents for a multi-site deployment. You would like to minimize the duplication, because thinking of the case of an upgrade of one of the components, you would not like to replicate the upgrade one by one for all the locations. Also, that the APIs that are used are too low level in most of the cases. So they require, actually in practice, they require coordinating a large set of resources that are quite low level. That's achievable, but requires some effort. And also, you need to interpret the joint state of the set of sets of resources, which is sometimes is hard, right? Of course, the creation of resources in the cloud that also requires monitoring the target cloud to some extent, and granting protection of sensitive data is quite important. You have a source of truth and you push in the history of that source of truth a secret value, probably that is one of the worst security practices. So you want to make sure that it's impossible to do that, right? So you can control that, so it's not possible in practice. And of course, if we are creating clusters that can host additional workloads on them, it's like having nested resource containers somehow. We need to manage that. We need to manage a process that is called Bootstrap. All that together brings a lot of complexity, right? So it's not easy to manage that complexity in a complex scenario. So that is when orchestration comes to rescue, because we can OSM guarantees that we can manage more conveniently those intents. And we can play a role in two places. One, of course, is decomposing high-level intents into low-level intents, and also we can that can be understood at this level, right? And also we can manage the transactions if needed. So many changes are coherent sets of changes are added together or reverted, and we can expose operations in the MBI as well. So we can encapsulate them conveniently. But also from OSM perspective, we can even facilitate the synchronization in some specific type of objects if needed. Okay. In release 16, there was the past release. This is not the new release, but leverage on this extensively. This is something that you know from past releases. We were introducing the cloud native operations. We were introducing the management of Kubernetes clusters, security enhancements, and so on. The point is that in release 17, we are going in that direction further, because now we are adding additional types of Kubernetes clusters that are supported. We are managing our network function catalog and the testing in a much better way, so we can publish the package of pre-onboarded network functions more conveniently. We can also use, we can incorporate in the new packaging blueprints for the new framework. Now we have some tooling to facilitate that. Their use for Helm-based applications, which are quite common, and also we can even generate end-to-end tests for all that automatically. Now we can improve. We have improved the parameterization of the network services. We have now the possibility of migrating, or at least having some relocation of the workloads in a large distributed Kubernetes deployment, and all that has come with improvements in different areas, like the OSM installation or the OSM client for making it much friendlier for common operations. And the thing is that, just to make sure that this is fully understood and what are the benefits, is that, as I said, in OSM is leveraging for the synchronization with the sources of truth with Flux. This does not prevent, and this is a common question, that in case that you want to combine it with other mechanisms for CD, this can be easily combined as well. So this is one of the strengths of choosing Flux in the first hand, because in the end, it does not interfere with other GitOps mechanisms that could be in place as well. And from the perspective of modeling the cloud resources, we are leveraging well-established projects in CNCF, like Crossplane for public clouds and PaaS, essentially, PaaS resources, and Cluster API for clusters that need to be built from the basic infrastructure and those clusters of Kubernetes clusters over different type of providers, and they can. This is a sound path for supporting this capability. So the thing is that with this approach, we can guarantee and realize the vision, right? OSM is adding new concepts. So it's not, as I said, we are not just synchronizing things. We are doing better on that. So the management of complex scenarios is easier. We added the concept of KSU, Kubernetes Software Unit, that is a set of manifests, essentially, that are managed and parameterized in a manner that can be based on an OSM blueprint, the OKA, that we will see in some minutes how they work. And the things that the KSUs are not managed on isolation. What we are asking in OSM is that the KSUs are grouped always in what we call profiles, right? You can have as many profiles as needed, right? And it's our way of saying all these KSUs need to be synchronized together, right? But as I said, the user can create as many profiles as needed. There's no limit, because it's just a grouping. Okay, and why this is important? Because the profiles can be attached to layers of synchronization of clusters, right? So that gives you a lot of control. So we have what we call the cluster intent. This is another new concept. In the cluster intent is where we have some synchronization layers pre-created. Nothing precludes that you could add manually more, but the thing is that as a minimum, you have these 4 layers of synchronization for the infrastructure controllers, the configuration of them that depends on having the infrastructure controllers ready, and also either the applications, network functions, or even cloud resources in case you are in a management cluster that can be deployed whenever that all the infrastructure, both controllers and infrastructure configurations, are reported to be ready. So here the thing is that the profiles that we have them, the profiles are attached, can be attached to those synchronization layers with the degree of freedom that multiple profiles can be attached to the same synchronization layer, and the same profile can be attached to different cluster intents. So there can be other clusters, and you can attach a profile to multiple clusters. And that concept facilitates that all the synchronizations happen in the desired order without requiring setting up all in this infrastructure that behind the hood is quite complicated. Okay. I mean, here there are examples of components that typically would be added in each of the categories, just to have an idea. And as I said, I mean, infrastructure controllers are mostly new functionalities and add-ons that we want to incorporate to the cluster. Infrastructure configurations typically are related to the setup of those controllers, and either the applications for a regular workload cluster or cloud resources for modeling resources in the remote clouds. And the thing is that, just to show you the example, I mean, if I create this is what you get when you have a new OSM deploy. You have already this intent created and these agents created in your management cluster, and this is in the synchronization. If I want to register some known clouds, I would add it here in the infrastructure configs, and that would be effectively configured for managing those remote clouds. And the point is that if we wanted to deploy a new application, I will be touching, a new cluster. I will be touching the cloud resources, and automatically that would lead to, say, the creation of a cluster in Azure, in this case, an AKS cluster. Moreover, the AKS cluster will be injected a Flux agent, so that Flux agent is also configured to obey the cluster intent for that cluster that we have created already. So the new request will not go through the management cluster, right? The cluster will be referring to our sources of truth directly, thanks to this schema. And so if I eventually fill in some of these layers, automatically that will lead to the deployment of some components in that cluster. It's as simple, with no direct intervention of the management cluster. Okay, that is the key. So say that now we deployed another cluster somewhere. Well, before that, so we can see it much better. I mean, actually, what I was saying was a simplification. So what is happening is that these profiles are attached to the different layers of the cluster, right? So I have some profiles attached to some layers. The things that say that I created another cluster, it will follow the same procedure now in Google Cloud. Okay, so far so good. So now I can decide to attach these same profiles to this other cluster intent. So automatically, the system will deploy the same applications and the same components if needed. Okay. And this is quite convenient, because say that I wanted to upgrade this OpenAir interface component, I will need to touch in here in P3, in the profile number 3. And just by touching in that profile, the changes will be automatically propagated to all the clusters that are affected by that profile, those the clusters where that profile is attached to, okay, automatically. So the maintenance, regardless of the number of clusters that I'm managing, becomes quite simple, and because I'm minimizing the surface where I need to implement changes. Okay, so that is the big change. So now Gerardo Garcia, TSE chair, will be explaining you how this cluster management works in practice in public clouds. So over to you, Gerardo.
Thank you, Francisco Javier. So, well, now what I'm going to try to illustrate is how OSM works in action with the additions that were done in release 16 and now in release 17. Okay, and basically I'm going to illustrate it in the context of the creation of infrastructure or management of infrastructure, in this case Kubernetes clusters in public clouds, and also the deployment of workloads in those Kubernetes clusters. So just a quick overview of what we are going to see. First of all, what we are going to see is that everything that we are doing since release 16, everything is modeled as Kubernetes objects. In this new declarative framework, we are modeling the creation of infrastructure and the deployment of services with Kubernetes objects. As Francisco Javier mentioned, we are using Crossplane and Cluster API. In the future, we will also consider KubeVir for other purposes. For the deployment of applications, we are using Flux customizations and Flux and releases, and you will see. And also, even internally, for our own workflows that we are running in OSM, we are running them in a declarative way using Argo workflows. Okay. Well, and just to make clear that it's understood, although I will show it through the demo, is that all the objects that we are creating, all the workflows and the infrastructure that we are creating it through a Git repo. We are making changes in a Git repo, and those changes are synchronized in the management cluster. But also, if the changes affect the destination cluster, the workload cluster, okay, well, this is with the example, for instance, of if we want to create a cluster or upgrade a cluster, everything is done in a Git repo, and this percolates to the destination cloud, okay? But if we want to do it if we are deploying an application or we are making changes in an application or in a profile, okay, that it's in the end associated to our workload clusters, those changes will be synchronized with the workload cluster conveniently. Okay, it's important you understand there are these levels of synchronization not only in the management cluster but also in the workload cluster, right? So first of all, what we are going to see in this demo, you will understand the declarative framework in OSM. You will see that there is a management cluster, that there are some Git repos, okay, and after that we will see some workflows. Particularly, we will check the cluster creation, the onboarding of an application or the onboarding of an OKA, and the deployment of an application or KSU, right? So in previous releases, what we have is a set of components that we're offering the imperative framework, okay? But now we have added new elements in an OSM installation. So whenever you install OSM since release 16, and now obviously also in release 17, is that we have included as part of the installation the setup of a Git repository. So whenever you install OSM, besides installing OSM, we are providing a Git repository. This is something that is optional. You could also use an external Git repository, but that's the default installation for standalone installations of OSM, right? And in addition, we are setting up a management cluster, okay? A management cluster that has the continuous deployment operators, such as Flux, the CRDs for creating infrastructure, and the crossplane CRDs, the cluster API CRDs, and the workflow engine to run our own workflows, okay? And well, one potential installation, the one that we will show today and the one that it comes by default, is with everything in a single Kubernetes cluster, but we could separate these components and have OSM components running in one cluster, the Git repository outside, and also the management cluster in a separate cluster, okay? So, well, that just to mention that whenever you have OSM installed, you have a Git repository that is provided by Gitea, that it's installed with OSM, with the standalone installation of OSM, as part of the installation process, right? So now I think that it's time for me to share my screen and start sharing the different well, workflows and how things work, right? So you can see here in the in my screen the typical well UI of OSM, okay, that we have since several releases ago, okay. This is the UI where you could see that, well, the dashboard, a typical dashboard, okay, that you have with OSM, right? In addition to that, we have also, as I mentioned, we have a Git repository that is deployed in OSM, that it's this Git repository that we could access, and it's running in the same cluster, right? And well, whenever you install OSM, you could check that. We could go to an OSM installation and check here, for instance, what are the things that are installed here. You see that there are some Argo system, FluxCD, the Gitea, etc. Well, that's part of the installation. You don't need to worry. Just to know that these components exist and they are doing some labor, okay, in this whole declarative framework, right? So let's start first with the first thing that we are going to do is we are going to create a cluster. So let's go to the K8s here, Kubernetes, K8s clusters, and let's create a cluster. We are going to call it webinar. Okay, the version that we are going to use is 1.30. The Vim account that we are going to use is an Azure account that we have added previously. I will call it this webinar cluster. The region name is North Europe. The resource group, in this case, I'm specifying because for Azure, we need the resource group. This is the resource group where the cluster will be created. The node count, let's say 2 nodes. And the node size, we need to provide here a flavor in the destination cloud in Azure. In this case, I will use this standard D2v2. Okay, and let's launch it. Okay, so now what's happening? Okay, and I hope that you understood from the previous presentation what's happening, but just in case it's not clear, I'm going to illustrate with a simple figure, right? So the request is sent, in this case, from the UI to the OSM northbound interface. This module is responsible of receiving the request, and if the request is authorized, it's passed to the lifecycle management module, okay? And once this lifecycle management module receives that request, what this module does is create a workflow, an internal workflow that it's declarative. It's based on a Kubernetes manifest, in this case, an Argo workflow, and it's that workflow is injected into the management cluster. Okay, so let's see that workflow here, okay, in my screen. Now, so this workflow should have arrived to the management cluster. I have here the UI of the Argo workflows, okay, so that we could see that workflow. And we see that there is a workflow here that says create cluster and an ID that corresponds to the ID of the operation, right? And you see here that there is this workflow is doing some stuff. In this case, we are generating some volumes where we are cloning the Git repos, okay? And then we are, in this case, creating the cluster that we are adding some manifests that are pushed to the Git repositories. So you see here that the workflow has been completed. That means that the workflow has made a push in Git. Let me go back to the slide so that you could get here the idea. You see that the workflow has arrived. The workflow right now is doing a push to the Git repository. So we are going to check if the push is there in the Git repository. And then once the push is done to the Git repository, the continuous deployment operator, in this case FluxCD, is synchronizing with this Git repository, okay? And we'll make sure that the cluster is created in the public cloud. So let's see that. So I'm going back to my screen here. I'm going to the Git repository. The Git repository here, we will go, there are 2 catalogs. In this case, we are going to the Fleet OSM catalog, and we can see here that there are, if we go to the history of commits, we see that 1 minute ago, there was a creation of a cluster. Okay, the cluster was called webinar at North Europe region. Okay, and you see here the files that were created in that when the cluster was created, those files were added to the Git repository. Okay, and now what is happening is OSM is continuously, well, as I mentioned before, the continuous deployment operator, in this case Flux, is making sure that this change is translated to the destination cloud, to the Azure account, and we can see here, if we go to OSM CTIO and we go here to the webinar repo, sorry, to the webinar Kubernetes cluster, we see that it's being created. And OSM during this process is continuously monitoring that that cluster is being created, right? We can see, for instance, in this screen here that I have, well, that the webinar cluster, let me show you here. For instance, here in this screen, it's a console screen. I can see the workflows that we're running, the pods of OSM, and the different resources that are being created in OSM. In this case, the webinar cluster is in creation. The resource has been synced in the destination account, but it's still in progress. Cluster creation takes some time. And for that reason, I'm going to proceed to another operation while the cluster is being created, right? And in that way, we will save some time. So the next thing that I'm going to do is, if I go back to the, sorry, here to the slides. As I mentioned, I wanted to show cluster creation, but also the application onboarding. So I'm going to show you how we can onboard an application, okay? An application in the end is a collection of manifests, okay? And an appropriate way to parameterize it, okay? That's basically an application or an OSM Kubernetes application, as we are calling it, an OKA. It's the name that we have used, okay? So let me show you through my screen here. Okay. Now you can see my screen, and I'm going to add here, I'm going to make it bigger. I'm going to run some commands. In this case, instead of the UI, I'm going to use the CLI just to illustrate that the commands are also available in the CLI. So I'm going to the folder where I have my OKAs, and I'm going there, and I'm going to show you an example, okay? So how an OKA is built? Well, in this, this is something that it has, I mean, this is adding a new way of creating packages in OSM. In the past, we have the CNF packages that are the common NFV way of packaging with a descriptor and a set of artifacts, okay? In this case, we are following here the declarative approach. So actually, what we are adding are the manifests that are telling how to deploy the application, right? So let me show you an example, okay? So let me show you this test ACME application. This test ACME application has a deployment and a service, other components, okay? And finally, a customization, that is the thing that is new. So you will, whenever you will need to create an application or an OKA, you need to create a folder for that application, for the OKA. Then under manifest, you put all the manifests for that application. And finally, in the customization, you add here a reference to those manifests, okay? This is the simplest example, okay, that you could see, and you see here the content. In this case, we are pointing to the manifest in that test ACME application, okay? And we are providing some convenient variables, okay? There is some documentation about that, but you can get the idea that it's simple. That's the case when you are having an application that it's based on some manifest, right? Let me show you, for instance, another common application, right? That it's a Helm chart, okay? How can we model a Helm chart? So in this case, we have this Jenkins application, okay? So let's take a look at that Jenkins application. Again, we have the manifest and the templates, okay? In the manifest, we can define what's the Helm chart that we are using. In this case, it's a Helm chart. The Helm repository is going to be called Bitnami charts, and this is the URL, okay? And also, besides that, we are adding another manifest that is the Helm release, okay? That is basically, it's based on this Helm chart, this version, okay, that comes from this repository, okay? Pretty simple, you get the idea, right? In addition to that, we have also provided some helpers in the OSM client. So if we check OSM client, the commands that we have, for instance, we see that there is a command that it's OKA generate that could help you to create a folder extractor so that you could start with, okay? And well, I think that that's, you can get more or less the idea of that. So I'm going to create to deploy the Jenkins application. So for that, I'm going to use this command, OSM OKA add. I'm going to add an OKA, an OSM Kubernetes application that is going to be called Jenkins. It's in this folder, the description, and the profile type. I need to tell if it's an app profile or if it's, if this OKA belongs to an app or an infra controller or an infra configuration, right? So I'm providing that. Well, and that's added, right? So now we will see again the same process as we were seeing before, right? Let me show you in the slides. Here. So as I mentioned, it's always the same, right? The request has arrived to OSM, to the MBI that sends it to LCM, that will launch the workflow, the Argo workflow in the management cluster. Then a commit will be done in the Git repository, and that commit will be synchronized from Fluxity and will make sure that this, well, if it has to synchronize with the cloud, it will do. But in this case, since it's only a package that is not distributed to any cloud, it will stop there, right? So let me show you how are things progressing. First of all, I'm going to show you that the cluster probably has been already created. So I will go back here. I will go back here. I will refresh my screen. Now the cluster is still being created. So probably it's 9 minutes right now. So it could take some time, but we will check, okay? And now in addition, let me show you what is going on here in the workflows. If we go to the workflows, we see, I will refresh that. Yeah. Well, it can take some time. The workflow to create the OKA, it will be launched pretty soon. Let me check also here that there is a progress here. Meanwhile, by the way, the cluster has just been created. Let me show you while the OKA workflow is being launched, okay? If I refresh right now, the cluster has been created, so it's in green. It's properly created. If we go to the public cloud, we should see, if I refresh this, that the cluster is properly created. And not only has been created, it has also been prepared to synchronize with the profiles, the appropriate profiles for that cluster, right? I will show you in a minute so that whenever we deploy an application, it will be synchronized with the management cluster, right? Or with the Git repository, sorry. You see that it's running, so everything is correct. Now let me check here the workflows. If I refresh, there is a workflow that it's creating the OKA. Okay, so this workflow will create will upload the package and will add this package to the Git repository. You see here the workflow. The workflow has been completed. It has ended. So now the OKA is created, and we could see also in here in this, we see packages, we see OKA packages, and we see that Jenkins is there. Okay. So what we can see is that we can see that the package was added to the repository. So let me show you. Instead of the Fleet OSM, there is another repository that is the software catalogs OSM. That's the one where the OKA will be added. If we check the commits, we see that there is a commit that tells create OKA Jenkins, that it's an app in the admin project in this case, right? So let's take a look, and we see that the folder was added, manifest templates, the same way as they were in the defining the OKA, right? And they were added to the software catalog. So far we have seen the creation of a cluster. We have seen the application onboarding, and now the next point is the deployment of an application, right? So let's go to that. Just let me remind what we will see, right? I will deploy an application, and again, the request will arrive to MBI that will send it to LCM. A workflow will be launched, and by the way, I don't know. I've been told that there is no audio from my side. Is that okay? Is it true?
No, we can hear you.
Okay, thank you. I've been told in the presenter chat that there was no audio, but thank you. So the workflow, as always, okay, what will happen in this declarative framework is always the same. The request arrives to LCM, that will launch a workflow. That workflow will create a commit, and that commit will in the end be synchronized, be pushed to the Git repository. That will be synchronized with the continuous deployment operator, and then it will arrive to the destination cloud. So let's see that, okay? I'm going to go here I'm going to share my screen now. Again. So now let me illustrate. So I'm going to deploy, in this case, the Jenkins application. So before I deploy that, what I'm going to show you is something that, well, maybe it could be interesting, is that when we created a cluster, 4 profiles were created, right? So we can see here that the webinar cluster has 4 profiles, and therefore 4 profiles were created. These are the 4 profiles that are created for the cluster. We can create additional profiles that are not default and could be shared between clusters, but by default, each cluster has 4 predefined profiles that are used to associate the different KSUs. In this case, we are going to deploy the KSU that is going to be the Jenkins KSU. Let me show you. So we are going to create a KSU. It's going to be called Jenkins. The description is Jenkins. The profile where we are going to deploy the KSU is webinar. And the profile type is an app profile, and it's based on the OKA Jenkins with some parameters. So I'm going to launch it, and I'm going to show you the parameters that we are using here. So in this case, we are telling that this Jenkins will be deployed in the Jenkins namespace, and in addition, that we are going to provide some parameters, in this case, a user and password. Okay. Well, so as always, the workflow should reach OSM. There is a workflow here in Argo Workflows that will generate some volumes, clone the repositories, create a commit, and that commit will be pushed to the Git repository. Okay, so in matter of few seconds, we will have the commit done in the Git repository. Here it's still cloning. Okay, the repos. So as you can see, more or less all the workflows are pretty similar. We are always preparing some volumes, cloning the repos there, and then doing some operations on the Git repositories. Depending on the operation that is receiving OSM, we are creating files, updating files, or deleting the files, right? In this case, where these are create operations, so we are adding files, right? And right now it's being pushed to Fleet, and when it's complete, that means that it has landed in the Git repository. So we go back to the Git repository, we check in the Fleet OSM repo, and we can go to the commits and see that 15 seconds ago, there was an operation that was create KSU Jenkins into the webinar profile. Okay, so these are the changes that were added, right? And now I think that, well, what OSM is doing right now is checking that the customization that is deployed in the destination cluster is properly deployed. So let me show you, and we can check in real time what's the progress of that. So we can, for instance, we can first of all download the kubeconfig file of the Kubernetes cluster. So let me check here, OSM cluster list. We can get the kubeconfig, the credentials of that webinar cluster. Okay, and we can parse them in YAML and put it in a file. Okay, kubeconfig webinar. Okay, and now I'm going to export that file. Export kubeconfig and check the nodes. kubectl get nodes. You see here, and we can check the progress of the customization. For instance, we can check in the destination cluster, in a subcluster, that the cluster is properly running. So we can check the progress. Oh, sorry. We can check the, I think that this is the progress of the customization, and we can also check the status in the Jenkins namespace. Okay, we see that the Jenkins customization has been deployed, and that Jenkins customization, well, obviously it's pointing to a hen release, and that hen release is being deployed, and that's what we see, that there are some objects that are being created, right? OSM meanwhile is monitoring always this, so we can see here that the KSU is in progress. Okay, in Git it was created, but the resource is not yet ready. Okay, OSM is continuously monitoring the status in the destination cluster, the status of the customization and the hen release in this case. Okay, and if in a few seconds it will be ready, OSM will know about that. Okay, and we could connect to the application and see that the application is working. Right. So this is in progress right now. So it's a matter of 10, 12 seconds and will be ready. More or less, it's 1.5 minutes, 2 minutes to have this application running. Okay, so hopefully it will be soon ready. Well, this is a live demo, okay, so that's I think it's good that you get the idea, and with a live demo, it's always times could be a little bit different, but I think that they are correct. Right now, the KSU is ready. You see here that the KSU it's created and the resource in Git, but also the resource is ready. So we can connect to the machine here to the Jenkins application. We could go here and use the user admin and the password that we set. Okay, and we can connect to the Jenkins, and we could see that it's working. Okay, well, it's in Spanish in this case because it's detecting my own language in my web browser, but you see here that there is a Jenkins. Well, and I think that that's all. I hope that you get the idea of this demo of the cluster management with well, in public clouds, and also how the different first-class citizens works, the clusters, also the idea of the profiles, the OKAs, and the KSUs, which are the actual instances. And sorry, I thought here, I think it's the right slide. So now I will pass the turn to my colleague Pedro Pereira, who is going to show you one of the new features in OSM Release 17, which is the relocation of CNFs in different cluster nodes. All yours, Pedro.
Hi, hi everyone. Thank you, Gerardo. Yes, so as Gerardo said, I will be doing a quick demonstration of the new feature for relocation of CNFs across different Kubernetes cluster nodes. So to start, a bit of a summary and context on this feature. So previously, in previous releases, OSM already supported the migration of VNFs right across different data center nodes. This, of course, is a very good feature because it serves as an enabler to use cases such as the upgrade of infrastructure nodes in a data center, for example. However, in release 17, CNF migration is introduced. So this feature allows for the migration of cloud native VNFs across nodes of the same Kubernetes cluster. This feature is very good because by integrating CNF migrating capabilities, OSM becomes more versatile and adaptable to contemporary infrastructure demands. This feature is critical in these cloud-native use cases because it is essential for ensuring operational efficiency, minimizing service downtime, and enabling smooth transitions across different environments. It enables use cases such as the upgrade of Kubernetes cluster with minimal disruption to the CNF, of course, and other edge scenarios, which I will pick up upon a bit later. Edge scenarios which require the distribution of applications in edge nodes close to the end user. To show you a bit of the scenario of what we are looking at here. So this would be a typical deployment where we have OSM communicating with the Kubernetes cluster, or more specifically, its control plane through the Kube API. And essentially what we're looking for is for the OSM to be able to communicate to the control plane a migration operation through through Kubernetes functionalities to allow for example, in the Kubernetes node, we have here a CNF deployment running along with other Kubernetes deployments in the Kubernetes node. Upon receiving this request, the Kubernetes cluster should be able to instantiate a new instance of this CNF in the node 2, for example, which right now works as the migration target node. Once the CNF deployment in the target node is up and running, then the previous instance, the old instance of this CNF deployment, will start terminating. After a while, it will terminate, and we will have remaining only the new instance in the migration target node, and the migration can be called, can be set as completed, which is our goal. So going into a bit of the technical approach to this feature and how it was realized. Essentially, through the upgrade function of a CNF, what it does is it uses the Helm upgrade operation to perform changes or upgrades, as the name indicates, to a certain Helm deployment. What we can do with this feature is utilizing a post render for manipulating the manifests during the Helm upgrade operation. We can bind this with the node selector field and include in it one or more of the target nodes of the migration target nodes labels. So if you look at Kubernetes node, it comes with these labels. As you can see in this example, we can see the type of architecture, the operating system, and one label that I find a bit distinguishable among a bit of an identifier among the nodes is the host name. So for example, you can see here the label says Kubernetes IO hostname K3S worker1 Pedro CGD Pereira. This label or any other label can be used along with the node selector field to specify where a deployment should be deployed. So if a deployment contains this node selector field with the Kubernetes IO hostname K3S worker1 Pedro CGD Pereira, this means that once the deployment is deployed in Kubernetes, the cluster will make sure that the target node will be one containing this label. Moving on to the Helm workflow and how this will be realized. Essentially, how Helm works is it takes the templated shards on input and takes additionally the configuration values, which come as the usual values.yaml file. Helm then generates and validates a set of Kubernetes manifests, and if no post render is supplied, then it just applies these manifests to Kubernetes and deploys them to obtain the Kubernetes object. However, if a post render is specified with a special post renderer flag, this post renderer is called. It receives the templated shard, the already generated and validated Kubernetes manifests. It receives them along with a set of parameters, a sort of input arguments. So what we can use these input arguments for is for the specification of the labels which we wish to inject into the manifests. This post renderer then does that. It patches the deployment, and we obtain on output valid Kubernetes manifests, which will then be applied to Kubernetes and deployed. Looking into how this post renderer was realized. So as I said, we have the rendered Kubernetes manifests and the labels specified in the certain format, key1, val1, key2, val2, etc. The first step is to take these Kubernetes manifests and save them into a file. So we have them all ordered. Then a patch to these manifests will be configured with the input. We can specify the node selector field and the labels that will be injected into each template that is contained into the all.yaml file. Through the use of the customized build tool, we can apply this patch to the manifests and obtain the Kubernetes manifest with the altered node selector field on output. Going back to the use case a bit of this feature, now that we're done with technicalities. This is the use case of the edge scenario, which I talked about previously, and it aims for enabling the relocation of Mac applications in a Mac NFV environment. Essentially, this scenario is one I picked up a lot, and the idea is to build an edge orchestrator that can use OSM to deploy Mac applications as CNFs. It can deploy these applications through interactions with OSM. It can terminate them through interactions with OSM, and it can even schedule migrations through OSM. So the idea is that an edge orchestrator will be able to schedule migrations with the NBI. This migration will then be communicated through the Kafka bus through a migration request. It will be communicated to the LCM, which will read it. And by interacting with the Kube API, it will execute this migration and allow the CNF to relocate between Kubernetes nodes. Oh, sorry, it took a little bit of time. Sorry, this feature is this scenario is very important. So this feature is essential in the scenario for various reasons. So in the scenario where user mobility is a high priority, the service must dynamically follow the user to maintain the connectivity and quality of service. So this feature is essential to ensure that the CNF can properly relocate between edge nodes and accompany the user, minimizing latency and maximizing the quality of service. Additionally, SLA assurance is also a very important topic in scenarios where we can monitor the resource utilization of Kubernetes nodes and the edge nodes. We can ensure that the CNFs that are deployed always follow the service level agreement of the Mac application and efficiently distribute the workload across the available resources and prevent overloaded nodes. To close, feel free to try out the proof of concept implementations, which was done in this for this scenario. We have two different ones. The first one focuses on the basic functionalities of being able to deploy Mac applications as DNFs and terminate them, while the Mac migration project is more focused on the migration aspect specifically and on the intelligence behind monitoring the environment and deciding whether it is necessary to perform a migration or not and execute it correctly. A bit of results on this project. Obviously, this project was very useful for various projects here at Instituto de Telecomunicações, as well as obviously my master's thesis, and also resulted in the writing of the full track paper and the demo paper. So all around a good result. I will then now share my screen to show you the demo, if I'll have just a second. I think you can see. Can everyone see right now?
Yes, we can see it properly, Pedro.
So you can see here we're on the OSM UI. Firstly, the first task will be to create this network instance. As you can see, it's a pre-recorded demo, so the delays that Gerardo has talked about, we will not see here because obviously I've shortened it a bit for practicality. Once the network service is deployed, so the CNF is now deployed, we will execute a migration of this CNF. You can see here, it's very important. I will pause so we can see it more clearer. Sorry. So you can see here in the Kubernetes cluster, we can see that the deployment is up and running, and it is running on the K3S worker 1 node. This is the current node that the deployment is running on. We can use this migrate command to specify the target host K8S labels. So once we specify that the labels we wish is the Kubernetes IO host name K3S worker 2, so the target node of this migration, this command will then mean that a migration will be scheduled in OSM, which will then communicate it to the Kubernetes API and execute this desired migration accordingly. Pardon me. So this migration is now ongoing. You can see here on the left side of the screen, a new instance will show up. It is creating on the K3S worker 2, and now it's very fast. It's already up and running, and the old instance is now terminating, which will take a little while. Once it's done, we have the K3S worker 2 instance running, and the initial instance is gone, and the migration is completed. Finally, the network instance will be deleted to finalize the demo. All went well. That is all from my part. I will go back to the slides and pass the word.
Okay, thank you, Pedro. Well, so now I think that is the time for taking some questions. So let me read some that I've arrived already. One is question is about how to register an isolated Kubernetes cluster in OSM without using a beam. Clarifies currently OSM provides a dummy beam for this process. Additionally, is OSM planning to provide a framework for developing custom beams? Who wants to take this one?
I can take this one.
Okay.
Yeah. So, well, the dummy beam is here is just a means to express no known beam here. I mean, no known beam. Okay, maybe the name dummy could be misleading here, but I think that you could understand it as a way to define a generic cloud site without a specific cloud engine behind, right? So I think that that's the meaning of dummy beam here. And so that's the question about the dummy beam. Regarding the framework for developing custom beams, well, it already exists. There is a plugin model in one of the modules of OSM, the resource orchestrator, that is the one that is responsible for talking directly to the beams, and well, that has been used in the past to add multiple beam types to OSM. So I think that framework exists, and if anyone has interest, we could give more details in a tech call or in Slack. Okay, no problem for that.
Okay, perfect. Thank you, Gerardo. So another question that we have is if I want to deploy a CNF, this one comes often. If I want to deploy a CNF, what do you recommend to create an OK or a CNF package? I assume that the traditional CNF packages. Maybe I can take this one.
Okay, yeah, go ahead.
The things, I mean, those mechanisms are slightly different, as you have seen, because they are injected to the different engines of OSM. In principle, my advice would be that if your use case for your application can fit in the new OKA framework, I would go for that one because that is more convenient. And I hope that after this webinar, it's clear that it offers a lot of advantages. However, that said, there is a possibility that first that the application does not support a fully declarative mode of operation. That's one total possibility. That's why the imperative engine is needed, because not all the applications behave properly in a cloud native world, unfortunately. So that is one reason. The other is that the functionality is not 100% the same in the case of the OKAs. The OKAs, I would say that following the Pareto rule, cover more than 80% of the cases, but there are still some set of the cases that are better handled at the CNS. Our plans are to evolve the OKAs so they can equalize in functionality the CNF packages very soon, so that will not be a dilemma anymore, and the imperative framework will only be left for non-cloud native applications that do not support declarative operations. But we are not yet there. So to sum up, if you can fit your use case in the OKA, clearly that is the channel. In case that there is some special functionality that is not yet supported in the OKA, then you should fall back with the traditional packaging for CNFs in OSM. Hope it's clear. Okay, so now there is another question. Hi, OSM team. I'm reaching out to seek clarification regarding notification support at the network service level in the OSM Pro. Specifically, I wanted to confirm whether notifications are currently supported at this level.
Yeah, I can take this one, Javier. Yes,
okay.
I think maybe I could share my screen because there are links in the documentation that are related to that, so I could probably
Okay,
point to that.
up to you.
Yeah. So, well, in general, notifications at BNF level are supported, okay, and I think that this should, if I go to the user guide and I check notification, I think that if we go to the reference of the northbound interface, here there are some, in section 12.14.2, BNF lifecycle management subscription notification support. There are some examples here on how to manage that. So in general, I think that, well, with this, probably someone with some experience on the notification aspects of HNFV specs would be enough. Anyway, if there is any more specific questions, what I can suggest is that the person who asked the question could contact us in Slack or join one of the Thursday's technical sessions that we have in OSM, and we could see the details, okay? But I think that from this documentation, probably he can start diving into.
Okay. Okay, perfect. So, okay. So now I'm checking. This another question. Can I use my existing clusters in OSM? I can take this one. The answer is yes, of course. You can. I mean, the fact that you can create new clusters in OSM does not mean that you cannot use pre-existing clusters, right? It was traditionally possible, and this is possible with the declarative framework, with the imperative framework, of course. The operation, just for clarifying it to you, in case you need to search for it, is called registering, okay? So that makes it simpler for you. Eventually, you will find in the same page that Gerardo has shown of the documentation, you can find the concrete commands to register your cluster, and the cluster is ready for being used for both engines, the imperative one and the declarative one. Okay. And actually, there are a number of additional options for fine-tuning that registration process. Okay, that's ready. This is another question. This is, what OSM capabilities do you lose when deploying KNFs in a bare metal cluster? I can take this one. None that I know.
Okay, go ahead.
No, yeah, no, that was my answer. I think that none.
No, I think that no. In general, you are not losing any capabilities. For instance, if you register the cluster in OSM, definitely nothing.
Mm-hmm. Okay, yeah. Okay. Okay. And there is another question on clarifying what version is stable of OSM in the releases, and it has another question on whether this webinar is recorded, so it can be rewatched later. Yeah, I'll answer the second one, but the first one is the more interesting. Of course, this one is recorded. You will see it offline if needed. But the interesting one is the technical one regarding the installations.
Yeah, well, definitely. I mean, the versions that I would suggest are always the latest ones, okay? But all the versions are stable. 16 and 17 are stable. The difference between both of them is that release 16, the version 16, is one that we will support for 2 years. We'll have a long-term support, okay? The other one, which is release 17, will have a standard support. The long-term support of release 16 is of 2 years of support. Okay, so we will provide patches and point releases during 2 years. The the standard release or non-LTS, okay, is 6 months support. So that's the difference. So, but always we are providing patches for releases. I suggest that you use one of the latest, either 16 or 17.
Mm-hmm. Okay. And stay tuned to point releases, etc., in case
Exactly.
that you want to get any potential bug fix or something. So you will gain.
For instance, there will be a new point release probably next week, okay, for both releases, for 16 and 17. So you could get let's say, the latest patches if you install OSM from next week.
Okay. And there is a last question here. What is the difference between an OKA and a CNF package?
Well, I think that we cover more or less, right, during the call, right, during the webinar. But
I mean, it's not a bad question, because in the end, the thing is that the CNF package follows an approach that is much closer to an HCNFV way of packaging things. And the OKA are more intended to manage Kubernetes-like manifest more naturally, so they are much simpler to trace and to incorporate. So onboarding is not a big task in general. It's simplified, although you can make things super complicated if needed. But in principle, the hello world for that packaging is quite direct. And I think that is more natural if you are more used to Kubernetes, but have no references whatsoever related to NFV. So that is the main difference. You can inspect the formats, etc., but that is the difference in the philosophy. And well, actually, we had another question that has just arrived. Do you consider how to manage artifacts or customization virtual objects, health charts, in order to orchestrate IoT elements? Well, maybe it's a bit confusing the premise, because with the part of the IoT, but I mean, there's no issue if the question is either probably related to the new framework or declarative orchestration. Of course, there's no issue with managing complex virtual objects such as Helm charts. Actually, they can be naturally incorporated and become a manifest if needed. So there's no limitation there. Actually, since we have chosen to leverage on Flux as much as possible, I mean, some of the CRDs that can be incorporated for alternative packaging formats. So even if we needed, and there were alternative packaging to Helm charts eventually in the future that were popular in the industry, it would be just as simple as adding a new controller to the management cluster. So that is the idea. I mean, whether that it can be a fabrication for IoT or not, yeah, why not? But in principle, we need to be ready for any environment from that perspective.
Yeah, I think that there are no further questions.
No, so I think
we're done.
We'll conclude the webinar, I think, Emmanuel.
Yeah, I think we're reaching the end of the webinar as well, time-wise. So thank you very much for providing this very good overview of OSM Release 17. And thank you for the audience for listening to us today, to you. Before ending, I would like to remind that the webinar will be available on demand together with the slides in PDF on the webinar page, so very shortly after the end. Our next webinar towards interoperable anchoring for XR will take place on the 4th of March, totally different topic. And you can already register for this webinar on the Etsy website and the BrightTalk channel. So before ending, very shortly, stay tuned. You can check out Etsy website to find out about upcoming events and webinars, also on the BrightTalk channel. So before closing, thank you very much again to our speakers for their presentation and to you all. So thank you very much, and I will now close the webinar. Stay tuned. Goodbye and thanks again. Bye-bye.
Bye-bye.
Bye.
Bye.